Hi, this is Carl Dominic T. Sanchez, and in this video, you will learn about the industrial wastewater treatment. When you wake up in the morning, you drink water, you brush your teeth, flush the toilet, and take a shower. That's just the first 30 minutes of your day. And you've already consumed a large amount of water. But have you ever think how you get a clean water despite of all the industrialization process that use and pollute the water? Water that is used in industrial processes is inevitably changed by the process. Chemicals are added and byproducts are picked up as the water moves through the system. As a result, industrial wastewater often requires treatment to remove solids, oil and grease, bacteria, regulated chemicals, and other substances before it can be reused or discharged to the environment. These are the sources of industrial wastewater. Breweries, where it can achieve an effluent discharge of 3 to 5 cubic meter. Dairy industry, where wastewater contain dissolved sugars and proteins, fats, and possibly residues of additives. Pulp and paper industry, which uses a huge amount of water in manufacturing process. Iron and steel industry, where it uses water as a lubricant and coolant. Nuclear industry, which is dealing with radioactive wastes. Food industry, which processing of food from raw materials requires large amount of high grade water. Here are the stages of wastewater treatment process. So stage 1 is bar screening. Bar screening is the removal of large items from the effluent to prevent damage to the facility's pumps, valves, and other equipment. The process of treating and reclaiming water from the wastewater starts with the expectation that after it is treated, it will be clean enough to re-enter the environment. Stage 2 is screening. It is the removal of grit by flowing the effluent over or through a grit chamber. Too small to be screened out, this grit needs to be removed from the grit chamber. There are several types of grit chambers: horizontal, aerated, or vortex, which control the flow of water, allowing the heavier grit to fall to the bottom of the chamber. Stage 3 is primary clarifier, initial separation of solid organic matter from wastewater. After grit removal, the effluent enters large primary clarifiers that separate out between 25 to 50% of solids in the effluent. These large clarifiers allowed for the heavy solids to sink to the bottom and the cleaner effluent to flow. So next, stage 4 is aeration. Air is pumped into the aeration tank or basin to encourage conversion of ammonia to nitrate and provide oxygen for bacteria to continue to propagate and grow. The primary function of the aeration tank is to pump oxygen into the tank and encourage the breakdown of organic material as well as ensure there is enough time for the organic material to be broken down. So next is number 5, secondary clarifier. Treated wastewater is pumped into a secondary clarifier to allow any remaining organic sediment to settle out of treated water flow. So as the effluent exits the aeration process, it flows into a secondary clarifier where, like the primary clarifier, any very small solids sink to the bottom of the tank. These small solids are called activated sludge and consist mostly of active bacteria. Number 6 is disinfection. So disinfection is done to kill any remaining bacteria in the contact chamber. So disinfection could be either chlorination, ozone disinfection, or UV disinfection. Chlorination disinfects the water through chemical disinfection, and chlorine is removed before it can be discharged through the environment. Ozone disinfection is a method that involves pumping an electrical current through the water to kill the bacteria. UV disinfection, the bacteria in the water are not killed, rather they are sterilized, making them harmless. Stage 7, water analysis and testing. Testing for proper pH level, ammonia, nitrates, phosphates, dissolved oxygen, and residual chlorine levels to conform to the plant's NPTES permit are critical to the plant's performance. Although testing is continuous throughout the wastewater treatment process to ensure optimal water flow, clarification, and aeration, final testing is done to make sure the effluent leaving the plants meets permit specifications. Plants that don't meet permit discharge levels are subject to fines and possible incarceration of the operator in charge. So lastly, stage 8, effluent disposal. After meeting all permit specifications, clean water is reintroduced into the environment. So those are the stages of wastewater treatment process, which covers the mechanisms and processes used to treat waters that have been contaminated in some way by anthropogenic, industrial, or commercial activities prior to its release into the environment or its reuse. Thanks for watching.